Hey guys, Mr. Mackenberg here. In this video, we're going to look at logarithmic re-expression.
Now sometimes as we're looking at data and as we're looking at scatter plots of data, the type of regression that we use can sometimes be pretty obvious to us. If we've got data that when we plot it out, it looks like it forms a nice straight line, then we would use linear regression or linreg. Or if we've got a set of data that as we plot it out, it looks sort of parabolic, then we would use quadratic regression. But it's not always very apparent what type of regression that we should use. So we can use a process called linearizing the data by using some logarithms to help us out. And that'll help us determine what type of regression is most appropriate for the data that we're working with. Now, it's also helpful to know things about the general shapes of these graphs that can help you determine what type of regression to use as well. But as we talk about our linearization, there's three different types of logarithmic re-expression that we can do with our data. So we're going to look at some general scatter plots. And these are just general x and y ordered pairs. But we're going to re-express this data by doing a natural log of either the x, the y, or possibly both to see if it linearizes our data. So if, when you're doing your linearization, let's say we were just doing the natural log of x, if that produces data that is linearized or looks like a straight line, then that tells us that natural logarithmic regression would be appropriate. So now let's look at a different scatter plot, and again, these are just general x and y ordered pairs, but let's say our data looked something like this time. So as we're doing our logarithmic re-expression, if we get linearization of our data by taking the natural log of our y value, if that produces a nice straight line within our data, then this is going to be exponential regression. Now there's one more type of logarithmic re-expression that we can do, and as we're looking at this new scatter plot of data that I'm giving you, it's going to look very similar to that last one that we did, but it is going to be slightly different, because the change that we're going to make to those x's and y's now is we're going to take the natural log of both the x and the y, and if that produces linearized data for us, then this is going to be power regression. So in this example, I'm giving you a set of data, and we want to decide if this data is best modeled by logarithmic, exponential, or power regression, and then find the actual regression model. So in order to figure this out, the first thing I want to look at is a scatter plot of the data to give me a general idea of what this would look like, and maybe that'll help lead me in the right direction. So I'm going to fire up my calculator. So the first thing I need to do is get my data typed in. So I'm going to go stat and then edit. I'm going to type in all of those x values in my list 1. And then I'm going to type in all of those y values in my list 2. And now I want to take a look at a scatter plot of the data. So I'm going to hit my y equals button. I need to arrow up to plot 1 and hit enter to make sure that that's highlighted. And then I'm going to hit zoom 9. And then on my graph, all of those data points should show up. Now, as I'm looking at this data, I can tell that it's definitely not going to be a logarithmic function, because a logarithmic function should increase rapidly at first and then start to level out as we go further to the right, and that's not what we have happening in our data. What's happening is as we move further to the right, our data is increasing more rapidly, meaning that this one is either going to be exponential or power regression. So to figure out which one we're going to use, we have to do that linear re-expression with our data. So I'm going to hit stat and then edit. And the first one I'm going to check for is the exponential regression. And what we have to do there is we're going to take all of those y values, so all of those data values in list 2, and we're going to do the natural log of all of them. So instead of 2 being my first data value, I'm going to do the natural log of 2. And then instead of 5, I'm going to do the natural log of 5, and so on down the line. So I've changed my data points, but only the y values. Now when I hit zoom 9, as I look at my data, it hasn't been linearized. It didn't produce a nice linear picture. So then I'm going to try a different type of logarithmic re-expression. So I'm going to hit Stat, and then I'm going to go back to Edit. The only other option is for this to be power regression. And in order to check for power regression, we need to do the natural log of the x and the y. Well, we've already done the natural log of all the y values, so I need to go through and do the natural log of all of those x values. Now when I hit Zoom 9, I get nice linearized data. I can see that my picture forms a straight line. So because we've linearized our data by using the natural log of the x and the y, that tells us that we should do power regression. So what I need to do is power regression using the original data from our table. So I'll have to hit my Stat button and hit Edit. I'll have to clear out the data that's currently in my lists and enter in the original data from that table that we were given. So I've re-entered in the data, and we said we wanted to do power regression. So I'm going to go Stat and go over to Calc, and I'm going to go down until I find power regression. I'll hit Enter. My data is entered in List 1 and List 2, so I'm going to go down to Calculate and hit Enter. So we've got this y equals a times x raised to the b power. We've got an a value and we've got a b value. So I should be able to write out my power regression model. So as I'm writing out this power model, it's going to go y equals that a value, which was about 1.809, times x raised to the b power, and our b value was about 1.63. So that power function is going to model our data. That's going to be it for this video. Thanks for watching.